Okay, this is the video for checkpoint 10. This is all of the side, like side, side angle, side angle, all of it in one thing. So we're going to look here at this figure. So we have 5.4, 5.4. There's an angle, and then between mark 2. So this is kind of confusing if you don't notice the 5.4 is the same. So it looks to me like, so it asks, is it possible to prove that they're true? They're congruent by side angle side, and say yes. Yes, there is, because there is a side, the angle in between and a side, angle in between, side. Good. And then Anna is standing on the roof of a 34-foot building, and it's located at point A. There's a 60-foot rope hanging from one point. When the rope is stretched out, it reaches point C. She wants to know how far she is from point B, how far she is from point B. So she's standing on the roof. She wants to know if, like, how far that is. So she's saying if she can show that they're congruent, she can find the distance from A to B, which segment lengths could be used to prove that they are the same. And let me just add a little caveat here. These lengths are actually impossible. And the reason why that is because this is a right triangle, and the only way that you could get that is technically by using the Pythagorean theorem on this. They did not go into that. These angles, these sides are not the same. But what they're trying to get at is we want to have two lengths that are the same to use side, angle, side, because we have that angle right there. We have those angles. So we want to show that this side is the same as that side. So we want to pick a BD and a CD length that are the same. So I can pick 8 feet and 8 feet. And is that the only ones that I can pick? So we have 6, no other 6s, 7, no other 7, 5, no other 5s, and 12. So that's what they're getting at, even though technically that is completely wrong because it doesn't fit the Pythagorean theorem. Then we have this one. Again, we have a side, angle in between and a side, angle in between and a side. So what do you know? What is true about them? Well, they are congruent. And how do we know? And let's see, to get from this one to this one. So let's see, going in clockwise order, A, C, B, and then D, E, F, we went, D, F, E is technically. So A, B, C is counterclockwise. D, E, F is also counterclockwise. So it was a rotation, and it is a rigid transformation. A rotation can map that onto there. And there we go. I think it's those that select 3 answers. There we go. Good. Next part, we have these 2 triangles. Again, side, angle, side, angle, side. Looks like we're good. A translation can be applied in a way that AB coincides with CD, coincides. So the main thing that you're looking for here is if you're doing these, that coincides is a big giveaway. Whoops. Big giveaway to what we're doing. So we are looking for endpoints A and C coincide with D and F. So there we go. And then use this information in the diagram to complete the proof. We first of all start with, always start with given. Then we have the measure of angle CAB is congruent to the measure of angle EAD. Those are vertical angles because they're pointing towards each other. They make a V. Oops, actually, I think we should go like this. Yep, vertical angles are congruent. That's just the definition of congruent angles. And then the 2 triangles are the same because of, let's see, we had side, angle, side. Yep. Side, angle, side. Okay. Next one. Last one. Ooh, lots of stuff here. I'm just going to look here. I'm going to make sure the angles are the same. So 37.8, 73.8, 72.4, 33.9. Okay. And then FD is across from 33.9. So we want to know how long that is here. So here's this one. Across from 33.9 is 3.4. So it also must be 3.4. And submit. And voila, 100%. Okay, good job.